in our mind. And when you think about it, this is why we actually do what we do. You heard a lot about this yesterday, that we do the science because ultimately we care about the patients. We also realize that translational medicine really takes a village. It needs to be a collaboration on multiple levels. And I think you've heard a lot about how the consortium really is a collaboratory. So it was not only a collaboration between institutions, but it was also a collaboration between organ systems. And not just between organ systems, but also between disciplines and approaches to those organ systems. So developmental biology, and engineering, and bioinformatics, and non-hypothesis discovery research, translation research, animal modeling, simple animal, things of that sort. So when you realize everything that was required to do translational research, we recognized that not all of that could go into the same building. But we then also realized that that didn't need to be that way. That one could have resident and non-resident programs, and then that the collaboratory is simply the physical home of a much broader consortium. And this broader consortium would include the hospitals, and the clinics, and big pharma, and the biotechs, and even those working in simple animals or systems that one would not even think of as being part of the stem cell mission. The ones, as Larry indicated, that we decided would be resident within there, and this was done with no any bias of any sort. We said neuroscience, cancer, diabetes, engineering, biomaterials, reproductive medicine, cancer, as I mentioned, would really have major homes within the consortium and within neuroscience, because neuroscience is so well represented, so heavily represented on the Mesa. That would include brain tumors, spinal cord injury, ALS, Parkinson's, Alzheimer's, stroke, lysosomal storage diseases, aging, things of that sort. So once we had had a sense of what this consortium represented in the field of translational medicine, we then had to figure out, well, how do we approach translational medicine? And I think, as Ed indicated, it was an immediate consensus that translational medicine still had to be mechanistically based. It had to be rational, evidence-based, because that's how you make the best progress in translational medicine. So when things work really well the first time, you could say, well, you don't really need to know the mechanism. But we know that's not how things work. Usually, they work a little bit. And then you want to know how to make them better. And the only way you're going to know how to make them better, how to troubleshoot, is to understand what it was you were doing. So from the very beginning, it was decided that even our translational mission would be very heavily rooted in basic science and in understanding mechanisms. It was also recognized that translational medicine is not just a single approach. There is no silver bullet. It's all multimodal. So that is why, for example, the engineers and the cell therapists and the gene therapists all get together. So for spinal cord injury, there's a lot of work on taking cells and combining them with scaffolds to provide support, provide templates. Even as we do drug discovery, we recognize we needed really first-rate chemists, medicinal chemists, to help us understand the leads and perfect the leads. So then how are we going to facilitate translation of the building? And I think you've heard about some of the cores that will really kind of facilitate and augment our ability to do really good translational medicine. So one aspect of translational medicine is transplantation. We plan to have, as you heard, really first-rate, amazing imaging facilities. If our vision's realized, this will be the premier imaging facility, probably in all of academia, definitely within the field of regenerative medicine and stem cell biology. We knew we needed really good animal models that could be assessed in terms of the behavior and the metabolism. We knew we needed a lot of facts of starting cells to make iPS cells and then the iPS cells themselves. And we needed really excellent drug discovery infrastructure, which I think we have in place. We even planned to have a cyclotron, as I had indicated, because we knew that we would need to see the fate of drugs and what their metabolism might be, in addition to looking at the cells. We also recognized that translational medicine was not just being insular, but that we needed to educate the public as to how good translational medicine is done. And I think that the kind of presence of medical tourism and a lot of what we hear indicates that the public doesn't understand entirely how you need to do translational medicine. But we could teach them, and education was part of that mission. It was also a place, because this is such a wonderful place to get together, that this would be a magnet for clinicians to come, for us to talk to them, for us to interact with them, teach them how the basic science may apply to their clinical problems, interact with the companies, Big Pharma, who actually make the drugs possible and make them accessible to the public. The occupants themselves, as Larry indicated, are exceedingly diverse. There are basic scientists, there are physician scientists, there are people in the building that you would maybe not consider to be your classic stem cell biologists, but they're important to the mission. And I think it's very telling that a good percentage of the CIRM disease teams are actually now represented or will be represented in this bill.